Hi everyone, thank you for joining. In this video we're going to solve another interesting integer equation. We are given that the x, y, z, a and k are non-negative integers and we want to find the values such that it will satisfy this equality. If you like to pause the video and try it yourself first, then we'll go over it together. Okay, let's start with some basic inspection. So let k to be 0, so that means we have x squared plus y squared plus z squared plus a squared is equal to 7 times 4 to the 0. So in other words, we have that whole thing is equal to 7. By inspection, we see that the set 2, 1, 1, 1 is a solution to this equation. And of course, all the permutations of this set. Now, if k is greater than or equal to 1, it is clear that the right-hand side of the equation, this bit here, is equal to 0 in mod 4. Well, this implies that x squared plus y squared plus z squared plus a squared is 0 in mod 4. And it follows that either x, y, z, a, all odd numbers, or all even numbers. One or the other, right? To see this, let's assume x, y, z are even, and let's choose one of them to be odd. So let's choose a to be odd. So what we have, then we have something like 2x dashed plus, well, squared, plus 2y dash squared, that's a squared plus, that's x squared plus y squared, plus 2z dash squared, plus 2a dashed plus 1 squared, because we're assuming this a to be an odd number, right? And as you can see that this will not equal to 0 in mod 4, because we have this term here. And you can test the other possibilities that you will come to a conclusion that all the numbers, they must have the same parity. They must either be all odd or even numbers, right? So there are two possibilities. So let's consider the possibility 1. I'll call it case 1. All odd numbers. So we have x squared plus y squared plus z squared plus a squared is equal to 7 times 4 to the power of k. Since they are all odd, we can replace them by 2x dashed plus 1 squared plus 2y dashed plus 1 squared plus 2z dashed plus 1 squared plus 2a dashed plus 1 squared is equal to 7 times 4 to the power of k, where x dashed, y dashed, z dashed and a dashed are non-negative integers. Now if we expand this and simplify, we'll get 4x dashed squared plus 4x dashed plus 1 plus 4y dash squared plus 4y dash plus 1 plus 4z dash squared plus 4z dash plus 1 plus 4a dashed squared plus 4a dashed plus 1. And that's equal to 7 4 to the power of k. And if we factorize it, we'll have 4x dashed into x dashed plus 1 plus 4y dashed into y dashed plus 1 plus 4z dashed z dashed plus 1 plus 4a dashed plus 1 plus 4 is equal to 7 times 4 to the k. Notice we get this 4 by adding these 1s here. So in other words, we can take that 4 on the other side. That will give us 7 times 4 to the power of k minus 4. And we can write it as 4, 7, 4 to the power k minus 1, right? Now, one thing to observe here is the left-hand side of this equation is divisible by 8. Divisible by 8. And using the fact that right-hand side is equal to left-hand side, that implies we must have 8 divides 4, 7 times 4k minus 1, Now, for this to be true, we must have 7 times 4k minus 1, an even number. But for what value of n this number can be even. Now the only possibility we have is that k is equal to 1. So from the original equation, we had x squared plus y squared plus z squared plus a squared is equal to 7 times 4 to the power of k. And if k is equal to 1, we have 4 to the power of 1, which is equal to 28, right? And again, now, if we write it neatly, we have x squared plus y squared plus z squared plus a squared is equal to 28. Now, by inspection, simply, we'll see that 3, 3, 3, 1 is a solution, or we could have 5, 1, 1, 1 is a solution. And of course, all permutations. Now, the case 2, where we have all the numbers are even, we have 2x dashed squared plus 2y dashed squared plus 2z dashed squared plus 2a dashed squared is equal to 7 times 4 to the power of k. So that implies we have x dash squared plus y dash squared plus z dash squared plus a dash squared is equal to 7 times 4 to the k minus 1, right? And again, by inspection, if this is equal to, let's say, 4k minus 1, and the same here, we have 3 of 4 to the power of k minus 1. And if this is 4 times 4 to the k minus 1, it adds up to 7 times 4 to the power of k minus 1. So in other words, if we say that x dashed squared is equal to y dashed squared is equal to z dash squared, which is equal to 4 to the power of k minus 1, we can write that as 2 to the power of 2k minus 1. So that implies x dashed is equal to y dashed is equal to z dash, square root of that, which is equal to 2 to the k minus 1. And we have a dashed squared is equal to 4k minus 1, which is equal to, well, that implies a is the square root of that, so square root of that will simply be 2 times 2 to the k minus 1. Since k is arbitrary, so we can replace k, we can let k to be k, capital K plus 1. The solution set will be 2 to the power of k, 2 to the power of k, 2 to the power of k, and 2 to the k plus 1. And of course, I should add all permutations here. Okay, so the next set of solution, if you look at the equation again, we have x dash squared plus y dash squared plus z dash squared plus a dash squared is equal to 7 times 4 to the power of k minus 1. If we let x dash squared to be 4 to the power of k minus 2, and if you say that's the same as y dash squared, and that is the same as z dash squared, in total, when we add them, we're going to have 3, 4 to the k minus 2. And then if we let a dash squared to be 25, 4 to the k minus 2, so in total, we will get 25 and 3, so that will be 28 times 4 to the k minus 2, which is equal to, well, 28 is 7 times 4, 4k minus 2, so that's equal to 7 times 4 to the power of k minus 1, apologies. So if you take the square root of it, then we will have x dashed is equal to, we said it was 4k to the minus 1, so we take the square root of that, so that is the same as 2k minus 1 square root of, and that's equal to 2 to the power of k minus 1. And that's equal to y dash, which is equal to z dashed, yeah? And we said a dashed squared was 25, 4 to the k minus 2. That implies a dashed is equal to 25, 4 to the k minus 2, square rooted, and that will give us 5 times 2 to the k minus 1. Again, let's define capital K to be k minus 1. Then the solution set will be 2 to the k, 2 to the k, 2 to the k, and 5 times 2 to the k, right? Now there is one more set of solutions, so I'll leave that to you as a challenge question. Okay, I hope you enjoyed it. I hope you found it interesting. Thank you very much for joining, and I look forward to seeing you in my future videos. Thank you.